Bismillahirrahmanirrahim. I am Muhammad Naveed and I am here to teach you a very important technique of integration, and this is integration by parts. And whenever students think about this, that when we have to use and how we have to use integration by parts, most of the time they are confused that why should we go for this technique. So first of all, we know that what is the importance and why is it used in the integration. So let's have a look at. First of all, remember this thing that whenever we don't have a direct integral available for any function, we have to use integration by parts. For example, there is a function natural log of x and we have to integrate it with respect to x. Now this is a function for which we don't have any direct integral available. There are many functions for which direct integration is possible, like if we have a function sin x and we have to integrate it with respect to x. So we know very well its integration is available, that is equal to minus cos of x, and that's all. But for such kind of functions we don't have direct integration available. This is case number first. Like, and we can take another example. For example, tan of x under root, and we have to integrate it with respect to x. Now for this function again we don't have direct integration available, so we will have to start by the parts method. So this is the case number first, and that's when we have to use this technique by parts. Now the second very important thing when we have to use this integration by parts is whenever there are two functions which are being multiplied. For instance, there is one function which is algebraic and the other is trigonometric. For example, x, this is algebraic function, and cos of x, this is trigonometric function. Now when we have algebraic and trigonometric being multiplied, we have to use integration by parts. We can take another example, exponential function, and multiply with the algebraic function. You will have to go for integration by parts. Similarly, we have a function, this is again exponential into algebraic. Now here you may also go for integration by substitution. Sometimes it's possible that there are more than 2 or 3 techniques available for solving a single problem. That's also possible. Like here we can go for the integration by substitution as well, but because we can also go for the integration by parts. Sometimes you are only stuck with one method when you don't have any other option. So at that time this integration by parts is very much important, and you have to use it by all means, because you don't have any other option. So sometimes it may happen that you have a lot of other options available, like here we have integration by substitution or any other technique, and by parts is also an option available with us. Now very important things which I have told you, that two ways when you don't have direct integration available, you will have to go for by parts. And secondly, when there are two functions being multiplied, whether these are algebraic and trigonometric, exponential and algebraic, or exponential or trigonometric, you will have to go for the integration by parts. Now we see how we have to use this integration by parts. We move ahead and we see that how we have to apply this technique. For example, we take two functions. First function is f of x and the second function is g dash of x, and we have to integrate it with respect to x. You can see that these are the two functions which are being multiplied. First may be the algebraic and the second may be the exponential, or whatever the case may be. Now we are having the integral available for this function, and we are going to put this function in the derivative. Now let me tell you one thing, that when you are choosing that which function you are going to set for the integral and what function you are going to set for having the differentiation, it's very important that you must be having good grip on both differentiation and integration. Otherwise sometimes you will be indulged in a very complex situation. So now what we have to do, we have to find out the integral of this function. So when we will find the integral, this will become g of x, and this f of x will remain as it is with it. Then we have the sign of negative, and integration of, and the derivative of this function f of x. Okay, so differentiation of the function f of x, and this function g of x will remain here as it is, g of x. So that's how we have to use and apply this technique of integration by parts. Now we see an example, and then you will clarify that how we are going to solve it. Now for example, we are having this function x into natural log of x, and we have to integrate it. First of all, we have to see that which function is we are going to take for differentiation and which function will be for the for which we have the integral available. Here we can see that integration of natural log of x is possible, but we don't have its direct integration available, so this cannot be put here for integral. We will go for this function x, and this is, we are going to put it on in integration, and this function is for the derivative. Clear? Now how we have to apply this technique? First of all, we will have to find out the integration of x, okay, and this is x square by 2, and natural log of x will be as it is, negative sign. Now we will put it here as it is, x square by 2, and we will take the derivative of natural log of x, and derivative of natural log of x is 1 by x, so 1 by x. Now here you can see x can be cancelled with this one. We are going to make it very much simple. X difficult for you to find out the integration of x with respect to x, and this is very simple, x square by 2. So what we are getting is 1 by 2 x square natural log of x minus 1 by 4 x square plus c. Okay, so you have to judge by yourself that which function should be in differentiation and which function should be in integration. Now we are going to solve this question, and first of all we will have to let this function equal to I for integration, and this is we are going to solve, do only in the questions of when we are going to solve it by integration parts. Reason is very simple, that sometimes we have a function which may be cyclic, and you may get the function repeated, so it's not very easy then to solve it again and again. So when it is going to repeat, we will simply put equal to I. So this happens mostly when you have the exponential and trigonometric functions in multiple form. So at that time trigonometric function may be cyclic and exponential function have repetition, so at that time it happens that function repeat itself. So anyhow, we generally represent all the functions with the I whenever we are going to solve it by this technique, integration by parts. So let's start. First of all, we see that which function should be in differentiation and which should be in integration. Here we can see that when we put it in for these both functions, we have both the things available. Integration is available, differentiation is available. Same as the case for x, we have integration available, we have differentiation available. So what should we do? We will put this function in algebraic function into differentiation and trigonometric in the integration. Why? Reason is very simple. When we differentiate the x, its value decreases, and as a result it vanishes, and when we integrate the x, its value increases, and it will go on increasing its value power, and on the other hand sin x will go on repeating itself, sin x then cos x then sin x then cos x, and it's never going to be a never ending question. So that is the reason we will have to put x in the differentiation and sin x into the integration. Okay, now we apply the method which we learned earlier. So here we are going to get the same. For x we are going to put in differentiation, so first of all you will write it here as it is, and sin x we are going to get cos of x. Okay, what is the integration of sin x? Minus cos of x, then minus sin. Now here we have differentiation for x, and this function as it is, that is minus cos of x. Now you can solve it, minus x cos of x. This is derivative of x with respect to x, very simple, it's 1, and here we have minus sign can be taken out, and this is cos of x dx. Now minus x cos of x, this will become minus positive, and for cos f integral is sin x. It's very simple to solve with the help of by parts technique, but it's very important that you should be clear that which function you have to put in differentiation and which function you have to put in integration. And this is whenever you have the algebraic and trigonometric, you will have to keep in mind that algebraic function should go into differentiation, so that its value, its power may decrease, and as a result eventually it will be vanished. Now here again we are having a very simple question, and we will have to see first of all that which function should be in differentiation and which function should be in integration. So, and have a look at this. We can see that natural log of x for this function we don't have direct integration available, so certainly we are compelled here to put it on differentiation, and the second option should go in integration. However, you might have seen that in the previous question we were going to put this algebraic function into differentiation, and the reason was very simple, that it may go decreasing its value and eventually it will be vanished. But here, because we don't have direct integration available for the second function, we will have to put it in the integration. Okay, we are compelled. Now we see, first of all you will have to let it equal to I. Okay, now we know the so now we are going to apply the same method here. First of all, what we are going to do, we are going to take the integration of a function x square. So its integration is x cubed by 3. Second function will remain as it is. The negative sign, f dash of x. What is f dash of x? Derivative of the second function, and that should be natural log of x, that should be 1 by x, and this function will remain there, x cubed by 3 as it is. Now you can see simplification is possible. We are going to do it. So here we have 1 by 3 x cubed natural log of x minus 1 by 3 and integral of x square. So very simple, x square can be integrated with respect to x, and the technique, it's very simple. Rule 2, x cubed by 3. Now in the last step you can simply simplify it. This is minus 1 by 9 x cubed plus c. So that's how we have integrated it with respect to x by using the technique of by parts.